In section 3, we're going to talk about frequency tables, and levels of measurement. We're going to start out though just kind of giving you a general rule for rounding. If we're calculating something like a mean or a standard deviation or a variance, something like that, we're going to give one more decimal place than was originally found in the data. Also, just keep in mind that a lot of times in stats, we might actually want to leave fractions unsimplified because it may give us a better understanding of what's really taking place in the data. So, not to say that you can't simplify fractions, but sometimes it conveys what's going on a little better if we leave them unsimplified. All right, we're going to next talk about levels of measurement. These are just kind of classifying data into different levels that tell us how informative the data is. Okay, so we say from lowest to highest, I mean lowest level of information. Okay, nominal tells us the least amount of things, and then ordinal gives us a little more, interval a little more, and finally ratio. So I have one slide for each of these categories so that we can hopefully fully understand what's going on here. The nominal level of measurement is where we just have qualitative data. Okay, the answers that we're getting here are names or labels, categories. They're not numbers. Okay, and so because of that, we can't order them in any meaningful way. Like if our labels are Presbyterian, Methodist, Baptist, Lutheran, okay, there's no real justifiable way to put those in any particular order, okay, outside of just like alphabetical order or something. But that has nothing to do with the actual data itself. The next level is ordinal, okay, and this is still typically not number answers, but now there is a meaningful order. So for example, our grade scale at NCCS, A, B, C, and F, that has a meaningful order, right? A is clearly the highest grade, B is the second highest, and so on and so forth, okay? These are, maybe like a top 5 list, like your top 5 favorite movies, okay? Well, you have a number 1 favorite ever, right? And you have a number 2, and you have a number 3. So there's a distinct order, but still our data is not numbers themselves. So because of that, it doesn't make sense for us to try to subtract data values, right? A B minus an A does not give you a C, for example. So now there's an order, but I can't really do anything with, I can't do any math with them yet. The next level is interval. And so now we have data that can be ordered, but now subtraction makes sense. So we're dealing with numbers. So one good example of this would be temperature, okay? If today it's 80 degrees and tomorrow it's 90 degrees, I can subtract those two and get a difference, right? But say we're in the winter time and one day is 20 degrees and the next day is 10 degrees, well, it doesn't make sense to say things like 20 is twice as hot as 10. Because if you're talking about the Fahrenheit scale, 20 degrees is still not very hot. So we wouldn't say something like twice as hot. So we can subtract, but we can't do twice as or half as much or those kinds of things. And the reason for that is there's no zero, right? There's no like this is the lowest it can get, zero floor. We know that temperatures in Fahrenheit can go into the negative values, right? So because that's the case, because we don't have a solid zero floor, we can't make those ratio comparisons like twice as much or half as much. All right, the final level of measurement, and this is what we call the most informative level, is the ratio level. So now there is a logical zero starting point, and so we can make those kinds of comparisons that I mentioned on the last slide. So say, for example, here this would be something like income, okay? If one person makes $50,000 a year and another person makes $100,000 a year, now it makes sense to say that that person makes twice as much money as the other person. Okay, so now we can make those ratio comparisons, and the reason we can is because there is a lowest value of 0. So those are the 4 levels: nominal, ordinal, interval, and ratio. All right, next we're going to turn to frequency. When you take samples, specifically when you take numerical samples, quantitative samples, um, it's likely that you're going to get a lot of answers that repeat, okay, depending on the kind of data that you're gathering. But for this one, it was, say you sample 20 students and you want to know how many hours a week or how many hours a day they work. So, there's only 24 hours in a day, and nobody works 24 hours. So, well, maybe firemen, but very rarely do you work 24 hours in a day. So the number of values you're going to get are fairly limited. So here in these 20 responses, we have these values. And one of the best ways to organize data like this is in what's called a frequency table. All right, so basically we count up how many times we got a particular response, and we organize the data in tables like this. So we had responses of 2 hours, and we got 3 different people that said 2 hours. So in our table for the first row, we have 2 hours, and we have that it occurred 3 times. Next, we had 3 hours. That occurs in our list 5 times, so our frequency is 5, and so on and so forth. Okay, so depending on how big your sample is, a frequency table can really help slim things down so you don't have so many numbers to look at. If you have a sample of 100 responses like this, well, then this table would really be a lot easier to look at than the 100 individual items. So the bigger the sample, the more helpful the frequency table. Second way of thinking about data is with relative frequency, and this is where we take each of these frequencies, and we turn them into either a percentage or a fraction, or just in some cases a decimal value. So if we take the same data that we had a moment ago, I've just added another column to that table where I'm expressing each of these as a percent. Okay, so the 3 responses that we got that were 2 hours represent 15% of the data. Okay, the 5 responses we got that were 3 hours represent 25% of the data, and so on and so forth. Okay, so these are relative frequencies. And like I said, you can do percents like I did, or you could do fractions, or you could just write decimal values, be 0.15 and 0.25 and etc. A third way that we can organize data is with a cumulative relative frequency. I've seen this written as also just cumulative frequency. The word relative doesn't always exist, but your textbook uses cumulative relative, so that's the way we'll refer to it. Basically what's happening here is we're taking a kind of a running total. Okay, so the third column here is the cumulative frequency. So in the first row there were 3 responses, so our cumulative count is 3. In the second row, see, we have 5 more responses added in, right? We have 5 people said 3 hours, so now the total of the 3 in the first row and now the new 5 gives us 8. So the cumulative frequency of the second row is 8. Then for the next row, we see we add 3 more, gives us 11. And the next row, we add 6 more, gives us 17, and so on and so forth. So by the time you get to the last row of a cumulative frequency table, you should have the total number of data values that we saw. So we had 20 people respond with the number of hours they work per day. So we see the last value of our table is 20. All right, so this section was considerably shorter than the first 2. Which is good. And so here I put page numbers accidentally. This is also out of the homework section. The page number may not be relevant because if you're looking at it online, you won't see page numbers. So homework section, and then these 5 problems will hopefully help you practice what we talked about. I'm not going to really go into section 1.4 in video form. This is a section that you just need to read. We're not really going to be designing a lot of experiments here. And then ethics. It's interesting, statistics is one of the only math subjects where ethics could even come into play. But you have to make sure that if you're trying to study psychological responses to various stimuli, that you're not doing something that's unethical. Please read section 1.4 for yourself. It'd be a great opportunity maybe to make a perusal comment or two. And thank you for your time, and I'll talk to you soon.